So, coming down to properties once again, uh, in an earlier session we learned about a chord drawn from the center to the midpoint of a chord. A line drawn from the center to the midpoint of a chord must be perpendicular to the chord and the converse of that property. Now, let's add some more very simple properties to circles. So one of the properties that's very commonly used is the property related to equal chords of a circle, right? What we want to establish is that if we have two equal chords, then these two equal chords in a circle must subtend equal angles at the center. Two equal chords must subtend equal angles at the center. It's a fairly simple to prove proposition. If this is a circle, and say this is one chord AB, and say this is another chord CD, and say these two chords are equal in length, AB is CD. That's given. Now what we want to show is that if O is the center, then the angle subtended by AB is actually angle AOB. Angle AOB is the angle subtended at the center. Angle AOB is the angle subtended at the center by AB. To prove that this must be equal to the angle that CD subtends at the center. That means this is the angle subtended by CD at the center. That means to prove that angle AOB is the same as angle COD. This is what we want to prove. The angle subtended by AB at the center, this angle, is the angle subtended by CD at the center, that is this angle. Okay, which means we wish to compare this triangle with this triangle. That means we want to compare triangles AOB and COD is what we want to compare. AOB and COD is what we want to compare. Now, realize that in the two triangles, AO is the same as CO. Why is that the case? Both represent the radii of the same circle. AO is CO. Right? Okay. OB is OD. And why is that the case? Why is OB equal to OD? Same reason as above. They represent radii of the same circle. So OB equal to OD. And then AB is DC. That's given. That's not me. That's given. AB is CD. That's given. Now, what comes through is a very simple little thing. In these two triangles, this side equal to this side equal to this side, and AB is the same as CD. AB is the same as CD, which means what? It means that the triangle AOB is identical in all respects with triangle COD. Why? That's out of the SSS condition for congruency. The SSS condition for congruency has led to the two triangles being identical in all respects. The side, the three sides of this triangle being equal to three sides of this triangle, the two triangles are then rendered identical in all respects, congruent. Therefore, the SSS condition for congruency. Therefore, angles opposite to equal sides in the two triangles must be equal. Now, AB is CD. Therefore, the angle opposite to AB, that means this angle, must be equal to angle opposite to CD, which is this angle. That means the simple conclusion out of congruency is angle AOB equals angle COD, which is what we set out to prove. The angle subtended by two equal chords at the center of a circle must be the same. Now, obviously, we wish to check the converse of this property. That means if we have two chords whose lengths are not known, But we can see that they are subtending equal angles at the center. We would then want to check if the two chords are equal or not. That means if there are two chords and they are known to subtend equal angles at the center, we wish to check if the two chords are equal or not. Let's examine that proposition. That means the converse of this property. The converse of this property meaning, if two chords subtend equal angles at the center, then the two chords must be equal in length. The two chords halfway down while I was writing all of this, my pen ditched me. I had to change the pen because it was running out of ink. And I hope that otherwise there is clarity in what I am writing here and all of you can see it clearly and neatly, right? You could compliment me for that. So if two chords subtend equal angles at the center, the two chords must be equal in length. That's a proposition we either want to prove or check, prove or disprove, right? So it's really the converse of the previous property. All right, it doesn't take too much of effort to examine this. So we have a chord AB and we have a chord CD. And what's known is that the two chords are subtending equal angles at the center. AB subtends an angle AOB, CD subtends an angle COD. They are known to subtend equal angles at the center. Angle AOB is angle COD. That's the angle subtended by AB at the center and CD at the center. That's given. Good. Now, realize once again, if I have to compare AB and CD, we wish to compare triangles AOB and triangle COD is what we want to compare, right? Now in these two triangles, AO is the same as OC, 1. OB is the same as OD. Hey, why is this the case? Tell me, why is AO equal to OC? You should have been very prompt with an answer for this. AO equal to OC because they are the radii of the same circle. As simple as that. And why is OB equal to OD? Why is that the case? Same reason. They represent the radii of the same circle. 3. Angle AOC the same as angle COD. Good. Side angle side, side angle side. The proposition then is the SAS rule for congruency. The side of this, angle of this, side of this, the side of this, angle of this, side of this. Side equal to side, included angle equal to included angle, then this side equal to this side. Therefore, out of the SAS condition for congruency, the triangle AOB is identical to triangle COD. The SAS condition for congruency. And therefore, if the two triangles are identical in all respects, the corresponding parts must be equal, angles or sides. Now, if these two angles are equal, the side opposite to this angle, AB, must be equal to side opposite to this angle, that is CD, which really means AB equal to CD. That means the converse of the property, previous property, gets established, gets authenticated, and we are in for good times. If two chords subtend equal angles at the center, there is nothing other than the two chords being equal, and the property whose converse was this. That means if there were two equal chords, they ought to subtend equal angles at the center. We are beginning to learn the cardinality related to circles very shortly. Wait for some more relevant and pertinent properties. Have fun, but stay put.